Okay, let's talk about the next wave of robotics, the next wave of AI, robotics, physical AI. So far, all of the AI that we've talked about is one computer. Data comes into one computer, lots of the world's, if you will, experience in digital text form. The AI imitates us by reading a lot of the language to predict the next words. It's imitating you by studying all of the patterns and all the other previous examples. Of course, it has to understand context and so on and so forth, but once it understands the context, it's essentially imitating you. We take all of the data, we put it into a system like DGX, we compress it into a large language model, trillions and trillions of parameters become billions and billions, trillions of tokens becomes billions of parameters, these billions of parameters becomes your AI. Well, in order for us to go to the next wave of AI, where the AI understands the physical world, we're gonna need 3 computers. The first computer is still the same computer. It's that AI computer that now it's gonna be watching video, and maybe it's doing synthetic data generation, and maybe there's a lot of human examples. Just as we have human examples in text form, we're gonna have human examples in articulation form, and the AIs will watch us, understand what is happening, and try to adapt it for themselves into the context. And because it can generalize with these foundation models, maybe these robots can also perform in the physical world fairly generally. So I just described, in very simple terms, essentially what just happened in large language models, except the ChatGPT moment for robotics may be right around the corner. And so we've been building the end-to-end systems for robotics for some time. I'm super, super proud of the work. We have the AI system, DGX. We have the lower system, which is called AGX, for autonomous systems, the world's first robotics processor. When we first built this thing, people are, what are you guys building? It's an SoC, it's one chip, it's designed to be very low power, but it's designed for high-speed sensor processing and AI. And so if you want to run transformers in a car, or you want to run transformers in a anything that moves, we have the perfect computer for you. It's called the Jetson. And so the DGX on top for training the AI, the Jetson is the autonomous processor, and in the middle, we need another computer. Whereas large language models have the benefit of you providing your examples and then doing reinforcement learning human feedback. What is the reinforcement learning human feedback of a robot? Well, it's reinforcement learning physical feedback. That's how you align the robot. That's how the robot knows that as it's learning these articulation capabilities and manipulation capabilities, it's going to adapt properly into the laws of physics. And so we need a simulation engine that represents the world digitally for the robot, so that the robot has a gym to go learn how to be a robot. We call that virtual world Omniverse. And the computer that runs Omniverse is called OVX. And OVX, the computer itself, is hosted in the Azure cloud. Okay? And so basically, we built these 3 things, these 3 systems. On top of it, we have algorithms for every single one. Now, I'm going to show you one super example of how AI and Omniverse are going to work together. The example I'm going to show you is kind of insane, but it's going to be very, very close to tomorrow. It's a robotics building. This robotics building is called a warehouse. Inside the robotics building are going to be some autonomous systems. Some of the autonomous systems are going to be called humans, and some of the autonomous systems are going to be called forklifts. And these autonomous systems are going to interact with each other, of course, autonomously, and it's going to be overlooked upon by this warehouse to keep everybody out of harm's way. The warehouse is essentially an air traffic controller. And whenever it sees something happening, it will redirect traffic and give new waypoints, just new waypoints to the robots and the people, and they'll know exactly what to do. This warehouse, this building, you can also talk to. Of course you could talk to it. Hey, SAP Center, how are you feeling today? For example. And so you could ask the warehouse the same questions. Basically, the system I just described will have Omniverse Cloud that's hosting the virtual simulation, and AI running on DGX Cloud, and all of this is running in real time. Let's take a look.
The future of heavy industries starts as a digital twin. The AI agents helping robots, workers, and infrastructure navigate unpredictable events in complex industrial spaces will be built and evaluated first in sophisticated digital twins. This Omniverse digital twin of a 100,000 square foot warehouse is operating as a simulation environment that integrates digital workers, AMRs running the Nvidia Isaac Perceptor stack, centralized activity maps of the entire warehouse from 100 simulated ceiling mount cameras using Nvidia Metropolis, and AMR route planning with Nvidia cuOpt. Software-in-loop testing of AI agents in this physically accurate simulated environment enables us to evaluate and refine how the system adapts to real-world unpredictability. Here, an incident occurs along this AMR's planned route, blocking its path as it moves to pick up a pallet. Nvidia Metropolis updates and sends a real-time occupancy map to cuOpt where a new optimal route is calculated. The AMR is enabled to see around corners and improve its mission efficiency. With generative AI-powered Metropolis Vision Foundation models, operators can even ask questions using natural language. The visual model understands nuanced activity and can offer immediate insights to improve operations. All of the sensor data is created in simulation and passed to the real-time AI, running as NVIDIA Inference Microservices, or NIMs. And when the AI is ready to be deployed in the physical twin, the real warehouse, we connect Metropolis and Isaac NIMs to real sensors with the ability for continuous improvement of both the digital twin and the AI models.
Isn't that incredible? And so, remember, a future facility, warehouse, factory, building will be software defined. And so the software is running. How else would you test the software? So you test the software to building, the warehouse, the optimization system in the digital twin. What about all the robots? All of those robots you were seeing just now, they're all running their own autonomous robotic stack. And so the way you integrate software in the future, CI/CD in the future, for robotic systems is with digital twins. We've made Omniverse a lot easier to access. We're going to create basically Omniverse cloud APIs, 4 simple API and a channel, and you can connect your application to it. So this is going to be as wonderfully, beautifully simple in the future that Omniverse is going to be. And with these APIs, you're going to have these magical digital twin capability. We also have turned Omniverse into an AI and integrated it with the ability to chat USD. The language of our language is, human, and Omniverse's language, as it turns out, is universal scene description. And so that language is rather complex, and so we've taught our Omniverse that language. And so you can speak to it in English, and it would directly generate USD. And it would talk back in USD, but converse back to you in English. You could also look for information in this world semantically. Instead of the world being encoded semantically in language, now it's encoded semantically in scenes. And so you could ask it of certain objects or certain conditions or certain scenarios, and it can go and find that scenario for you. It also can collaborate with you in generation. You could design some things in 3D, it could simulate some things in 3D, or you could use AI to generate something in 3D. Let's take a look at how this is all going to work. We have a great partnership with Siemens. Siemens is the world's largest industrial engineering and operations platform. You've seen now so many different companies in the industrial space. Heavy industries is one of the greatest final frontiers of IT. And we finally now have the necessary technology to go and make a real impact. Siemens is building the industrial metaverse. And today we're announcing that Siemens is connecting their crown jewel accelerator to NVIDIA Omniverse. Let's take a look.
Siemens technologies transform the everyday for everyone. Teamcenter X, our leading product lifecycle management software from the Siemens Accelerator platform, is used every day by our customers to develop and deliver products at scale. Now we are bringing the real and the digital worlds even closer by integrating NVIDIA AI and Omniverse technologies into Teamcenter X. Omniverse APIs enable data interoperability and physics-based rendering to industrial scale design and manufacturing projects. Our customers, HD&A, market leader in sustainable ship manufacturing, builds ammonia and hydrogen-powered ships, often comprising over 7 million discrete parts. With Omniverse APIs, Teamcenter X lets companies like HD Hyundai unify and visualize these massive engineering data sets interactively and integrate generative AI to generate 3D objects or HDRI backgrounds to see their projects in context. The result? An ultra-intuitive, photoreal, physics-based digital twin that eliminates waste and errors, delivering huge savings in cost and time. And we are building this for collaboration, whether across more Siemens accelerator tools like Siemens NX or Star CCM+, or across teams working on their favorite devices in the same scene together. And this is just the beginning. Working with Nvidia, we will bring accelerated computing, generative AI, and Omniverse integration across the Siemens accelerator portfolio.
The professional voice actor happens to be a good friend of mine, Roland Busch, who happens to be the CEO of Siemens. Once you get Omniverse connected into your workflow, your ecosystem, from the beginning of your design to engineering, to manufacturing planning, all the way to digital twin operations. Once you connect everything together, it's insane how much productivity you can get. And it's just really, really wonderful. All of a sudden, everybody's operating on the same ground truth. You don't have to exchange data and convert data, make mistakes. Everybody is working on the same ground truth. From the design department to the art department, the architecture department, all the way to the engineering and even the marketing department. Let's take a look at how Nissan has integrated Omniverse into their workflow. And it's all because it's connected by all these wonderful tools and these developers that we're working with. Take a look.
每一种颜色都能使这款车型焕发出独特的魅力。
我喜欢有质感些的灰色。
非常好的选择。
That was not an animation, that was Omniverse. Today we're announcing that Omniverse Cloud streams to the Vision Pro. And it is very, very strange that you walk around virtual doors when I was getting out of that car, and everybody does it. It is really, really quite amazing. Vision Pro connected to Omniverse portals you into Omniverse. And because all of these CAD tools and all these different design tools are now integrated and connected to Omniverse, you can have this type of workflow. Really incredible. Let's talk about robotics. Everything that moves will be robotic. There's no question about that. It's safer, it's more convenient, And one of the largest industries is going to be automotive. We build the robotic stack from top to bottom, as I was mentioned, from the computer system, but in the case of self-driving cars, including the self-driving car application. At the end of this year, or I guess beginning of next year, we will be shipping in Mercedes, and then shortly after that, JLR. And so these autonomous robotic systems are software-defined. They take a lot of work to do, has computer vision, has obviously artificial intelligence, control and planning, all kinds of very complicated technology, and takes years to refine. We're building the entire stack. However, we open up our entire stack for all of the automotive industry. This is just the way we work. The way we work in every single industry, we try to build as much of it as we can so that we understand it, but then we open it up so that everybody can access it. Whether you would like to buy just our computer, which is the world's only full, functional, safe ASIL-D system that can run AI, this functional, safe ASIL-D quality computer, or the operating system on top, or, of course, our data centers, which is in basically every AV company in the world. However you would like to enjoy it, we're delighted by it. Today, we're announcing that BYD, the world's largest EV company, is adopting our next generation. It's called Thor. Thor is designed for transformer engines. Thor, our next generation AV computer, will be used by BYD. You probably don't know this fact, that we have over 1 million robotics developers. We created Jetson, this robotics computer. We're so proud of it. The amount of software that goes on top of it is insane. But the reason why we can do it at all is because it's 100% CUDA compatible. Everything that we do in our company is in service of our developers. And by us being able to maintain this rich ecosystem and make it compatible with everything that you access from us, we can bring all of that incredible capability to this little tiny computer we call Jetson, a robotics computer. We also today are announcing this incredibly advanced new SDK. We call it Isaac Perceptor. Isaac Perceptor, most of the robots today are pre-programmed. They're either following rails on the ground, digital rails, or they'd be following APRO tags. But in the future, they're going to have perception. And the reason why you want that is so that you could easily program it. You say, would you like to go from point A to point B? And it will figure out a way to navigate its way there. So by only programming waypoints, the entire route could be adaptive. The entire environment could be reprogrammed, just as I showed you at the very beginning with the warehouse. You can't do that with pre-programmed AGVs. If those boxes fall down, they just all gum up and they just wait there for somebody to come clear it. And so now, with the Isaac Perceptor, we have incredible state-of-the-art vision odometry, 3D reconstruction, and in addition to 3D reconstruction, depth perception. The reason for that is so that you can have two modalities to keep an eye on what's happening in the world. Isaac Perceptor. The most used robot today is a manipulator, manufacturing arms, and they are also pre-programmed. The computer vision algorithms, the AI algorithms, the control and path planning algorithms that are geometry aware, incredibly computationally intensive. We have made these CUDA accelerated. So we have the world's first CUDA accelerated motion planner that is geometry aware. You put something in front of it, it comes up with a new plan and articulates around it. It has excellent perception for pose estimation of a 3D object. Not its pose in 2D, but its pose in 3D. So it has to imagine what's around and how best to grab it. So the foundation pose, the grip foundation, and the articulation algorithms are now available. We call it Isaac Manipulator. And they also just run on NVIDIA's computers. We are starting to do some really great work in the next generation of robotics. The next generation of robotics will likely be a humanoid robotics. We now have the necessary technology, and as I was describing earlier, the necessary technology to imagine generalized human robotics. In a way, human robotics is likely easier, and the reason for that is because we have a lot more imitation training data that we can provide the robots, because we are constructed in a very similar way. it is very likely that the humanoid robotics will be much more useful in our world because we created the world to be something that we can interoperate in and work well in. And the way that we set up our workstations and manufacturing and logistics, they were designed for humans. They were designed for people. And so these humanoid robotics will likely be much more productive to deploy. While we're creating, just like we're doing with the others, the entire stack. Starting from the top, a foundation model that learns from watching video, human examples. It could be in video form, it could be in virtual reality form. We then created a gym for it called Isaac Reinforcement Learning Gym, which allows the humanoid robot to learn how to adapt to the physical world. And then an incredible computer, the same computer that's going to go into a robotic car, this computer will run inside a humanoid robot called Thor. It's designed for transformer engines. We've combined several of these into one video. This is something that you're going to really love. Take a look.
It's not enough for humans to imagine. We have to invent and explore and push beyond what's been done.
A fair amount of detail.
We create smarter and faster. We push it to fail so it can learn. We teach it, then help it teach itself. We broaden its understanding to take on new challenges with absolute precision and succeed. We make it perceive and move and even reason so it can share our world with us. This is where inspiration leads us, the next frontier. This is Nvidia Project Groot. A general-purpose foundation model for humanoid robot learning. The Groot model takes multimodal instructions and past interactions as input and produces the next action for the robot to execute. We developed Isaac Lab, a robot learning application to train Groot on Omniverse Isaac Sim. And we scale out with Osmo, a new compute orchestration service that coordinates workflows across DGX systems for training and OVX systems for simulation. With these tools, we can train Groot in physically based simulation and transfer zero shot to the real world. The Groot model will enable a robot to learn from a handful of human demonstrations, so it can help with everyday tasks and emulate human movement just by observing us. This is made possible with NVIDIA's technologies that can understand humans from videos, train models in simulation, and ultimately deploy them directly to physical robots. Connecting Groot to a large language model even allows it to generate motions by following natural language instructions.
Hi, GL1. Can you give me a high five?
Sure thing. Let's high five.
Can you give us some cool moves?
Sure. Check this out.
All this incredible intelligence is powered by the new Jetson Thor robotics chips, designed for Groot, built for the future. With Isaac Lab, Osmo, and Groot, we're providing the building blocks for the next generation of AI-powered robotics.
About the same size. The soul of Nvidia, the intersection of computer graphics, physics, artificial intelligence. It all came to bear at this moment. The name of that project, General Robotics 003. I know, super good. Super good. Well, I think we have some special guests. Do we? Hey guys. So I understand you guys are powered by Jetson. They're powered by Jetsons, little Jetson robotics computers inside. They learn to walk in Isaac Sim. Ladies and gentlemen, this is orange, and this is the famous green. They are the BDX robots of Disney. Amazing Disney research. Come on, you guys, let's wrap up. Let's go. 5 things. Where are you going? I sit right here. Don't be afraid. Come here, Green. Hurry up. What are you saying? No, it's not time to eat. It's not time to eat. I'll give you a snack in a moment. Let me finish up real quick. Come on, Green, hurry up. Stop wasting time. 5 things. 5 things. First, a new industrial revolution. Every data center should be accelerated. $1 trillion worth of installed data centers will become modernized over the next several years. Second, because of the computational capability we brought to bear, a new way of doing software has emerged, generative AI, which is going to create new infrastructure dedicated to doing one thing and one thing only. Not for multi-user data centers, but AI generators. These AI generation will create incredibly valuable software. A new industrial revolution. Second, the computer of this revolution, the computer of this generation, generative AI, trillion parameters, Blackwell, insane amounts of computers and computing. Third, I'm trying to concentrate. Good job. Third, new computer creates new types of software. New type of software should be distributed in a new way so that it can, on the one hand, be an endpoint in the cloud and easy to use, but still allow you to take it with you because it is your intelligence. Your intelligence should be packaged up in a way that allows you to take it with you. We call them NIMs. And third, these NIMs are going to help you create a new type of application for the future. Not one that you wrote completely from scratch, but you're going to integrate them like teams. Create these applications. We have a fantastic capability between NIMs, the AI technology, the tools, NeMo, and the infrastructure DGX Cloud in our AI Foundry to help you create proprietary applications, proprietary chatbots. And then lastly, everything that moves in the future will be robotic. You're not going to be the only one. And these robotic systems, whether they are humanoid, AMRs, self-driving cars, forklifts, manipulating arms, they will all need one thing. Giant stadiums, warehouses, factories. There can be factories that are robotic, orchestrating factories, manufacturing lines that are robotics, building cars that are robotics. These systems all need one thing. They need a platform, a digital twin platform, and we call that Omniverse, the operating system of the robotics world. These are the 5 things that we talked about today. What does NVIDIA look like? What does NVIDIA look like? When we talk about GPUs, there's a very different image that I have when people ask me about GPUs. First, I see a bunch of software stacks and things like that. And second, I see this. This is what we announced to you today. This is Blackwell. This is the platform. Amazing, amazing processors, NVLink switches, networking systems, and the system design is a miracle. This is Blackwell, and this to me is what a GPU looks like in my mind. Listen, orange, green, I think we have one more treat for everybody. What do you think? Should we? Okay, we have one more thing to show you. Roll it. Thank you. Have a great GTC. Thank you all for coming. Thank you.